what are the FLEXvalue tools? What are we really talking about here when we get into the details? There's basically three components of this toolkit. On one hand, the data itself is very, very valuable and can be used for lots of different purposes. And it's a little bit hard to get to at times. So one of the things that we've done in releasing this open source code package is to put together databases that you can download directly. So among these databases include the electric and gas utility avoided costs. If you're familiar with the avoided cost calculator itself, it's something that the CPUC puts forward every year. And E3, the consultant, has done a lot of great work in putting together the avoided cost. This is a really phenomenal resource. But the avoided cost data comes in the form of a Excel macro-driven workbook. And so you kind of need to toggle through many, many different scenarios in order to pull the cost information that you ultimately want. It's a lot of sort of manual copy pasting. We've pulled all of that information for every utility, climate zone, year combination, and we've pulled it all into one central database. And you can download that database as a CSV or as a SQLite table and just use it directly. You can query it directly, and there's no sort of macro-driven interface that you have to sort of, figure out in order to get these data at your fingertips. Also, GHG emissions rates are included in these database tables, and then we have deemed load shapes. So all of the DEER load shapes for all of the utilities, we have, you can just go download them directly. And then we have the calculator itself. So this is kind of like the main package. This is the fully functioning Python code base. It's a cost effectiveness tool in and of itself. You can use, again, custom 8760 or the DEER load shapes. It has a notebook user interface, and we'll talk about this and we'll demonstrate it in a minute. And then it's fully documented. So we'll talk a little bit about where you can find all of the nitty-gritty details in the documentation in a moment. And then finally, there's a CET and FLEXvalue comparison tool. This is a tool that, like I said, that allows you to simultaneously generate input files and then parse outputs and compare them directly. So what does it actually take to run a FLEXvalue calculation? This is an example of an input file. So if you upload this as an input file, as a CSV, directly into FLEXvalue, this is what you need in order to run a cost effectiveness calculation with FLEXvalue. Again, this is everything. You're not missing anything at this point. If you're using just DEER load shapes, this is all you need to run cost effectiveness. Now, I want to draw specific attention to this, this one field. So let me back up just a minute. Let's walk through this just for a minute. So you have an ID for every row. Each row contains a load shape. So each one of these rows could be like a measure or a program that you're reporting. It would typically be a row that would just go into the cost effectiveness tool. So if I just look at the second row, for example, I give it an ID, I call in a load shape, I give it a start year and a start quarter. So we have an ID, we give it a load shape, we give it a start year and a start quarter, the utility, a climate zone, the units. So this is just like if you have multiple units, that's basically saying, we're installing this measure more than once. An EUL, a net to gross. You can actually input the discount rate into FLEXvalue. So this is something that if you want to investigate the impact that the discount rate is having on cost effectiveness, you can change this discount rate. We have it set as a default of the discount rate that PG&E utilizes for cost effectiveness calculations, which is 7.66%. And then we have admin, measure, and incentive costs, the therms profile that you would typically incorporate into the CET. And then you have your savings information. So therm savings and megawatt hour savings, these are annual savings. Now, looking specifically at this load shape column, what FLEXvalue will do is it's going to look at each of these load shapes and it's going to say, if this load shape is stored in the database that I mentioned earlier, then FLEXvalue is going to use that load shape. So for instance, this is one of the DEER load shapes. It's the residential HVAC air conditioning load shape. And if you input this load shape, it's going to pull that 8760 profile directly from the FLEXvalue database. And it's just going to use that for the cost effectiveness calculation for that row. Similarly, the HVAC chillers on the non-res side, that's another example of a DEER load shape. But you may notice this res heat pump electrification. This is not a DEER load shape. It's not something that FLEXvalue is going to recognize as a pre-stored load shape. So if you have a load shape that doesn't match what's already in the database, then FLEXvalue is going to expect that you're uploading a second file. In this second file is the 8760 load shape for whatever you want to put in here. So in this case, this is actually, what I'm showing is actually the load shape for electrification, heat pump electrification that we've measured for SMUD. And so this is the load shape that, this is the impact on the electric grid for an average heat pump installation, replacing a furnace in SMUD territory. And if FLEXvalue doesn't see the load shape as being in the DEER database, then it's going to look for this very same column in the metered load shape table, and then it's going to pull that data directly into the cost effectiveness calculation. So again, if you're only using pre-stored load shapes, then this user inputs file is all you need. If you're wanting to use custom load shapes, then you just have to make sure that you're titling that load shape the same as the column heading in the metered load shape table that you're also providing, and we'll show you exactly how to do this. Currently, we have, I think, 17 or 18 DEER load shapes that are in FLEXvalue. This is an understatement because PG&E and SCE and SDG&E and SoCalGas all have different variations on these DEER load shapes. So for example, the residential indoor CFL lighting load shape is different for PG&E versus SCE and SDG&E. And so we've incorporated all of these load shapes, and this automatically, the proper load shape automatically gets selected because you're including in the FLEXvalue input the utility. So it's just going to pair that utility with the DEER load shape in order to pick the proper DEER load shape for the calculation. And then finally, just a note on load shape normalization. The DEER load shapes are all normalized, meaning if you add them all up across all 8760 hours of the year, you get a value of 1.0. And because they're normalized, when you then include a megawatt hour savings or if it's kilowatt hour savings in the CET, then those savings get distributed across that 8760 profile according to how the DEER load shape weights each hour of the year. In FLEXvalue, you can provide normalized load shapes, in which case in that savings column, you would just use it the same way you would use the CET. Or alternatively, you can put in a load shape that's not normalized that actually has the values, you know, across those 8760 hours that you're intending. And in that case, you would just put in 1 in the savings column. So if we look at this res heat pump electrification, then I'm just putting 1 in the megawatt hour savings because this load shape already has the absolute magnitude of the values that I'm looking for. So again, just use this accordingly and you'll be fine.